Hi everyone! Have you ever wondered what bottles, shoe soles, toys, and plastics in general are made from?
Well, they are made out of small chemical molecules called monomers that link together form chains of monomers named polymers.
Polyethylene is a polymer formed by 18 monomers.
Let's find out more about it.
The initial synthesis of polyethylene is attributed to many. In 1898, Hans von Pechmann prepared it by accident while heating diisomethane. His colleagues Eubank Berger and Friedrich Schissler characterized the white solid as containing methylene units and called it polyethylene. Polyethylene from the ethylene monomer was probably initially synthesized by M.E.P. Friedrich while a graduate student worked for Carl S. Marble in 1930, when it was an unwanted byproduct from the reaction of the ethylene and lithium alkyl compound. In 1932, British scientists in the Imperial Chemical Industries (ICI) accidentally made polyethylene while they were looking at what products could be produced from the high pressure of the ethylene with various compounds.
A polymer formed by the direct repeated addition of monomer is called addition polymerization. In this case, ethylene monomers linked together form polyethylene. Polyethylene can be produced using radical, anionic, cationic, and ion coordination polymerization. This is a result of the lack of substituents on the ethylene monomer. Let's look at the free radical polymerization. Peroxides are today routinely used to initiate polymerizations, as they readily break down to give peroxide radicals. This radical, with its unshared electron, is highly reactive and can then add a monomer by pairing up with an electron stolen from the double bond of a vinyl molecule, or replacing the sticks representing bonds by dots representing electrons, where each pair of electrons represents a single covalent bond. This whole process is called initiation. The next step is the propagation of the chain, which usually proceeds rapidly. The reaction terminates when two radicals meet through the process of ordinary random collisions.
In order to obtain pure ethylene, scrubbers are used, which act as columns in which the components with the lowest boiling point, such as methane and hydrogen, evaporate and exit through the head of the column. The higher boiling components, such as ethene, and the immediately higher hydrocarbons with a lot of ethylene meet at the bottom of the column. It is believed that by adding alcohol and sulfuric acid, ethylene will be obtained with a little energy. When you check bromine water and potassium permanganate, as both are one color, if ethylene was actually obtained, it will make these substances transparent.
An ethylene has a structure of two carbons linked by a double bond and two hydrogens attached to each carbon. In the double bond, one bond is a sigma as the other is a pi bond. This molecule has hybridization sp². The sp² orbitals are at 120 degrees to each other. Carbon-carbon double bond length is at 1.33 angstroms. Today there exists a wide variety of polyethylenes that vary in extent of length of branching as well as molecular weight distribution, and amount of crystallinity. Commercial low-density polyethylene (LDPE) typically has between 14 and 15 short alkyl branches for every 1,000 ethylene units. It is produced using high pressures and temperatures. It has a density of about 0.912 to 0.935. Because of the branching, the LDPD is amorphous because of the branching and low amount of crystallinity. LDPD has a low melting point of about 100 Celsius degrees, making it unsuitable for uses requiring sterilization using boiling water. LDPE has a combination of short to long branches at a rate of about 10 short branches to every long branch. High-density polyethylene, produced using organometallic catalysts such as the Ziegler-Natta or Phillips catalysts, have less than 15 short alkyl branches for 1,000 ethylene units. because of the regular structure of the ethylene units themselves and the low extent of branching. HDPE chains can pack more efficiently, resulting in a material with greater crystallinity, higher density with increased chemical resistance, hardness, stiffness, barrier properties, melting point, and tensile strength. Low molecular weight. HDPE is a wax, while typically HDPE is a tough plastic.
Ethylene is the raw material used in the manufacture of polymers such as polyethylene, polyethylene terephthalate, polyvinyl chloride, and polyestyrene, as well as fibers and other organic chemicals. These products are used in a wide variety of industrial and consumer markets such as the packaging, transportation, textile, and construction industries, as well as consumer chemicals, coatings, and adhesives. The largest outlet, accounting for 60% of ethylene demand globally, is polyethylene. Ethene is used in the production of ethylene glycol, which is used as automotive antifreeze agent, used in the production of ethanol, used in the production of styrene, which is polymerized to form polyestyrene. Low-density polyethylene and linear low-density polyethylene are used in food and non-food packaging, sandwich bags, cling wrap, liners for tanks and ponds, shrink and stretch film, squeeze bottles, and as moisture barriers in construction. High-density polyethylene is used in blow molding and injection molding applications, such as household goods, containers, drums, caps, wire and cable insulation, pallets, freezer bags, pipes for water, gas and irrigation, carrier bags, industrial lining, and extrusion coating. Ethene is used in the production of ethylene glycol, which is used to precipitate out proteins from solution, often as an intermediary step in fractionation, purification, and crystallization.
A mixture of ethylene and nitrogen supplied in cylinders is used to control the ripening of fruits, especially bananas. It is also used in agriculture to stimulate crop growth. It is used as sealing layer in the field applications and control permeation packaging for vegetables and fruits.
Environmental impacts for ethylene production are greenhouse gas emission, water pollution, among others. Ethylene produced for agriculture produces soil pollution. Fuels produce pollution both when used and produced. One of the most serious problems is the air pollution with CO2. This is caused by burning fuels for obtaining or transforming the ethylene. In 2016, approximately 37 million tons of dioxide were emitted to the atmosphere. Packaging materials made from polyethylene have negative environmental impacts on the land and water. The land is polluted by a large accumulation of non-biodegradable plastic. In oceans, this accumulation of plastic threatens the life of marine plants, animals, and seabirds.